Good afternoon, students. Am I audible clearly? Good afternoon, students. Am I audible clearly? Am I audible clearly? Okay, so thank you for the reply. So let us start with the today's class. So yesterday we started with the fourth chapter in the syllabus, that is machine learning. So in this chapter, we are learning about few of the concepts of the machine learning and what are the types of the machine learning algorithms. And then we will go for the regression methods as well. So here, this is the syllabus that we already have taken the overview. That is, first we will study about the machine learning concept, that is what is meant by overfitting and what is meant by train and test splits. The next types of machine learning, that is supervised, unsupervised, reinforced learning. Then the third point we will see is introduction to Bayes' theorem. And last one, we will go for the studying linear regression. Okay, so here we will be performing model assumptions, regulations, and there are three ways: lasso, reach, and heuristic. So okay, so this is the syllabus. Then we started with the first point, that is, even though we are learning a data science subject, why we are learning machine learning in the subject? So here, machine learning, it means that we are trying to automate a task by designing some mathematical model. Okay, so here it means data science is equivalent to the machine learning. Yes, not equivalent, but we can say machine learning is involved into a data science, and the data scientists mostly build and train quick machine learning models all the day long. It means that here, if you wanted to learn how my data works, for this purpose, we are designing models, and the designing model is itself called as a machine learning. That is, I wanted to find out how my data gets changed, or which are the facts and figures which are interrelated, etc. It means that here, if consider I'm describing some product or describing some cells, so here, or describing some values, some characteristics. So these are all referred in terms of some values or properties or variables in terms of matrix, etc. So it means that, for example, if I'm talking about this laptop, so in this laptop, I will see what is the name of my laptop, which company it produced, then what are the dimensions, what is weight, then which processor it is, etc. It means that there are many properties which belongs to this laptop. Similarly, I can have many laptops, and within that, if I wanted to find out the performance, etc., then I will find out what is the relation between these variables. That is, I wanted to find out of my Dell products, which one is most widely sold and which is giving much more profit to my company, and as well as that is which product is much more recommended by the customers. That is why the reviews are different for each of the products, where I can see some bad reviews as well as some good reviews. So good reviews results to that customer satisfaction is there. So here, whenever we are trying to find out this relation, it means that we are trying to learn what is the relationship between the variables, and that relationship. Okay, any of the student is having a doubt? So here, if consider, that is, whatever my business problems are there, where I wanted to find out where sales are reducing, where sales are increasing, where profit is not there, where profit I can gain much more. So it means that whatever these business problems are there, we are converting into data problems, and converting these business problems into data problems, it means that I'm collecting data, understanding those data, cleaning and formatting, where we apply some filters so that we will see only interested part of the data. And then After it means after that we will apply the machine learning within that. So it means that here whatever this procedure is there which we are performing in terms of data values, that is nothing but a machine learning. Okay, so machine learning here we are referring that building a mathematical model. Okay, so at this point I wanted to ask whether do you face any other chaos during the lecture or voice is clear? Do you face any other difficulty? Any otherwise noise? If no, then we will proceed. Okay, then we started with the machine learning concepts. So then we have seen what is meant by model. So model, it is simply a specification of mathematical or probabilistic relationship that exists between our different variables. So here variables, it means that I'm referring to a set of data values, a set of different properties, a set of different vectors or elements of my matrix, etc. So the business model is probably based on the simple mathematical relationship, that is profit is revenue minus expenses. That is, if I'm talking about the mathematical model, then we can say that profit is revenue minus expenses. It means whatever I'm getting at the end, that is revenue, and from that I will deduct my expenses. Then I can say that that much profit I have gained. Then revenue is units sold times average price. So it means that here we are talking in terms of average price as well. That is at what price our goods are sold and what is the time duration, etc. So it means that there are multiple uh, attributes are there which will define whether I'm in loss or I'm in profit, etc. So then we started with the machine learning. So machine learning refers to creating and using models that are learned from the data. That is building a model. This might be called as a predictive modeling. Predictive. Here the main word is that predictive, it means that we cannot say that if we are defining a mathematical relation for all the cases this will become true. No, here whatever this model or whatever mathematical relation we have built, this may having the accuracy less than 100% as well. That is, for each and every data input whatever I'm giving, it may not give the correct result. For example, I have given the 100 values, for that it is giving me the required value. But if I'm entering 101, that is the 100 and plus value, then it may not give me the correct answer. So in that case we can say that here predictive, it means that this might happen. Okay, this might happen, the probability is there, or it may be happen, etc. So here the main thing is that all these things are implying the choices, or we are dealing with the customers or humans. Okay, so consider that today I read the slide, I like the slide, so I press the like. But tomorrow some other resources I have referred, and I come to know that this slide is not giving me the clear idea, but whatever the another resource is there, this is giving me the clear idea. That is, I would prefer that resource other than this slide. Okay, so it means that here at this point tomorrow I may not like this slide. So it means that here I will prefer, I will use. So that is completely based on the human nature. And predictive, it means that we are referring to the behavior of the previous data values, and on this behavior we are making some conclusions. So conclusion remark or whatever the result we are having, that is always true, or that need to be true for the 100 percentage. That is not a mandatory rule. Okay, even though predictive modeling works better than the 90%, etc. That is also quite, it means perfect model we can say. Okay, so here is the goal: use existing data to develop models that we can use to predict various outcomes for new data, such as whether predicting whether an email message is spam or not. Okay, so here in the spam, wherever I'm referring that, email which are having some advertisement, etc., those are automatically shifted to the spam folder. Okay, so in the email we are having different categories like inbox, sent, outbox, or draft, etc. Within that, spam is also there. Spam will have a collection of those emails which are advertised, and it means which are common to all, etc. So it means that each time, if I'm having the 100 emails into my spam, I cannot guarantee that each one of that is also a spam. Here, this is working on some keywords model, or this, whether the given message is spam or not, that is decided based on the machine learning algorithm. So each time this will give the correct answer, that is not decided. So sometimes we may receive a verification email into the spam, etc. as well. So it means that we can say that those are the exceptional cases of our prediction model or predictive model. And in such cases, we cannot stick to the point that it should be 100% correct. No, here this might be having a some negative answers or incorrect results as well. Okay, next, predicting whether a credit card transaction is fraudulent. So here, whenever I'm performing a transaction, so I may feel that that is a fraud, a fraud payment, etc. So in that case, we may go for some background check, etc. And here it means based on this data values, it will decide whether the given transaction is fraud or a normal transaction. Then predicting which advertisement a shopper is most likely to click on. So here, whenever we are talking about the likes and dislikes of the person, then we may change. So if consider based on the hundred or thousands of the customers data, if most of them have clicked on the single advertisement multiple times, then we can say that that advertisement is mostly likely to be clicked by the customers or shopper. Then in that case, we might give a much more rating for that. The next, predicting which football team is going to win the Super Bowl. So here again, whether here predicting, it means that we cannot write a fixed rule. Okay, fixed rule, it means that whatever statement I am making, that will be true in all the circumstances. No, there might be exception where even though I'm giving the analysis based on the 100 cases or 99 cases where everywhere my guess is correct, then it might get filled at the next case, etc. So prediction, it means that this might happen, that we are talking about. Next, overfitting. We have seen overfitting, it means that we are having the train data on our model. Then on the train data, if we pass the test data as well, if this is giving the same functionality as that of the model, then we can say that is a generalization. So training data, whatever model we have built on the training data, if it works correctly with the test data as well, then we can say that the uh, model is a generalized model or correct model or correct formula. Whereas if we are talking about overfitting and underfitting, it means that here underfitting, whatever the model I have designed, neither a training data also works properly on that. So here the meaning is that here underfitting, it means that I'm having two types of the data, training and test. Training, it means that where my data is labeled. For example, consider classification. In the classification, if I'm giving the 100 samples, then I will also know that out of these 100 samples, which one belongs to which category. Okay, so here that will be our training data where each one of the sample is labeled. Whereas when it comes to the overfitting model, it means that it is working correctly with the training data, but when it comes to test data, performance may get degraded or performance is not shown. So in such cases, we can say that overfitting is there. Okay, so overfitting occurs when you fit a model too closely to particulars of the training set and obtain a model that works well on the training set. Okay, overfitting model works well on the training set but is not able to generalize to new data. Whatever new test data is there, on that it is not working properly. Okay, and in case of underfitting, we can say that this is not properly working on the training data as well. So here we are seeing the example. So here conclusion is that we wanted to design a complex model so that it will give us the correct. If we are going for the simple models, then it may go for overfitting or underfitting, etc. But when it comes to the complex problems, then chances of generalization are more. So here we have seen the example of buying a boat based on the customer data, and then we have made one complex rule and one is a simple rule. So by using a complex rule, we can say that accuracy of this result is 100%, whereas accuracy of the next result is very less. Okay, so that is a uh, training and test data. Then we have seen what is meant by train and test splits. So training, where I have already data labeled. Test splits, where I don't have to which class or which category my data belongs. So in case of test, result is output is unknown, whereas in training, output is already known. Next, we will start with the second point in the chapter syllabus, that is types of machine learning, that is supervised, unsupervised, and reinforced learning. So before moving to the second point, let me know, do you face any problem in this first point? If no, then we will go for the next point. Okay, so these are the types of machine learning, that is supervised, unsupervised, and reinforced learning. So let us go for studying what is meant by supervised learning. So before that, what are the ways that is, okay, so it means machine cannot learn in the single way or there is not only single method for learning. So there are three ways or three methods through which machine can learn. So each method is having its own advantages and disadvantages. So for knowing what is the advantage of each of the method, let us see these methods one by one. So in machine learning, there are two kinds of the data. First, so okay, this is not a ML type of algorithm. No, here we are talking about the data, that is labeled data and unlabeled data. So what is meant by label data? Label data has both input and output parameters in a completely machine readable pattern, but requires a lot of human labor to label the data to begin with. Okay, so label the data, it means that whenever I'm deciding a sample, so if consider I'm deciding into three, that is 100 samples are there, and I want to perform a classification. Then within that, or consider that I wanted to decide whether, okay, let us take an example of the classification only. So if consider I'm having data of 100 flowers, okay, and I wanted to identify whether that flower is hibiscus or whether that flower is mogra, or other than these two, the third category I will have the remaining flowers. Okay, so here this might happen that here whenever we are talking about the training data, whatever training data I'm having, that is 100 flowers data. So within that, along with the input, that is, for example, I will have properties like color, how many petals are there, how much diameter is there, what is the stigma length, or etc. It means when I'm deciding for the mentioning the characteristics, it will have many more. So within that, whatever these characteristics are there, so these characteristics, along with this input data, color, etc., these properties, I will also have a label at it. Label it means that Initially, I will know whether that flower is hibiscus, mogra, or another flower. That is, if I'm talking about hibiscus as class 1, mogra as class 2, and third category will be class 3. Then, initially, whenever I'm providing the training data, along with the input values, I will have the label as well. Label in which class my data belongs. Okay. म्हणजे माझा whatever flowers, 100 flowers are there, each one will be having the output class as well. The first flower is mogra, second flower is hibiscus, third flower is mogra as well, fourth, fifth, sixth, all these are mogra, 7th to 12, these are the hibiscus, and then remaining are the other flowers, etc. It means that here initially I know input as well as output is also known. Okay, so then if we are having the known that data belongs to which class or output, that is called as a labeled data. Labeled data, by providing or initially before providing the data only, I know that in which class that uh, uh, data will fall or in which class that flower will fall. So for this purpose, we need for labeling a human labor is required. That is, explicitly we need to mention that this one category belongs to class 1, this flower belongs to category 2 or class 2, etc. Whereas when it comes to the unlabeled data, only has one or none of the parameters. Okay, so in machine readable form, here we are having input and output, which can be read by the machine. But whereas this unlabeled data doesn't have a machine readable form. So this negates the need for human labor, but requires more complex solution. So in case of unlabeled data, we need to find out the characteristics by our own without the human interference. And whatever data we are providing, that is not in a machine readable format. And that's why here we need a complex solution that if I'm providing the 100 data of the flowers, so this will learn. It will not have the output like in which class that 100 data will be preferred. It may go for that is without human intervention. The machine learning algorithms will study that features and based on that, it will decide the output of that product, output of that flower or item, etc. Clear with this? What is in the label data and unlabeled data? Okay, listen, this point is much more important. So please read this definition carefully for a minute. Then we will go for the actual supervised learning definition. So, okay, there are also types of machine learning algorithms that are used in very specific use cases. So use cases, it means that it means as per the need, we will change the algorithm or as per the need, we will decide which method to be applied here. So there are many methods are there. So out of that, the most important are three, that is supervised learning, unsupervised learning, and reinforcement learning. Okay, so out of that, whatever the supervised learning is there, that method is a task driven. Unsupervised learning is data driven. And in case of reinforcement learning, this is learned from the error approach. Okay, so these three are the approaches which are used respectively with these three methods. Okay, I'm having spelling mistake here and supervised learning. N is extra here. So then next, let us start with what is meant by a supervised learning method. So supervised learning is one of the most basic types of the machine learning. In this type, the machine learning algorithm is trained on the label data. Okay. So here trained, it means that I inserted data, I come with the conclusion, I designed a model, I again inserted data, check, then model. So it means that here training, it means that I'm giving input and output, and based on that, it is deciding what model or what is mathematical model it should use, what formula should use, or which steps it should follow to get that output. If input is given this, etc. It means that here based on the input and output combination, so it will train itself. Output, it means that that is a label is there, that is in which class my item will fall. So here this algorithm learns itself by using a trained data where I am having input and output. So here trained data is very less. It means if I wanted to test on the lakhs of the tuples or lakhs of the data, then I may give thousands, etc. Or trained data, that is 110, 120 or 30%, etc. Even though the data needs to be labeled accurately for this method to work, supervised learning is extremely powerful when used with the right circumstances. So, okay, it means here data is already labeled. Okay, so here, even though it means we need a data to be labeled, which is it means quite a extra work. Then still, this will be much more powerful whenever we are using into a right circumstances or right use, etc. In supervised learning, machine learning algorithm is given a small training data set to work with. Any of the student is having a doubt? I can see the disturbance. So in supervised learning, we are having machine learning algorithm is given small training data set to work with. That is, here we wanted to build a model which will satisfy the given input and output combination. This training data set is smaller part of the bigger data set and serves to give the algorithm a basic idea of the problem, solution, and data points to deal with. So here, whenever we are building a model, there might be some exception cases. So exception cases, it means that for this combination of data values, I may have a different output, etc. So it means that how these each of the cases should be dealt, what is the problem, what can be the solution, and where the data points we have to deal with the extra care. So then next, training data set is also very similar to this final data set in the characteristics and provides the algorithm with the labeled parameters required for the problem. Okay, so here, whatever training data set we are giving, that is exactly similar to the final data set. Final data set, it means that for which I wanted to find out the class, for which I wanted to study the features, etc. Or I may having the 1 month data of the customers as a training data, and based on that, I will decide what strategy should be applied for the having customers into the 11 remaining months. Okay, so here it means that for the first month, whatever data I'm giving for building the machine learning algorithm, that will be called as the training data. And training data is also called as a labeled parameters. That is, a class is already known. And then we will study the algorithm and will work on the test data. Then algorithm then finds the relationship between the parameters given, essentially establishing a cause and effect relationship between the variables in data set. And at the end of training, the algorithm has an idea of how data works and relationship between the input and the output. Okay, so here it means that here after the training, okay, I'm training, it means that checking whether this input for this model, whether output will be there. for this input, whether same model is giving me the answer. If not, how I need to modify, whether it works on the previous cases, current case, etc. So it means that here, based on the input and output, we will train our algorithm, and then we will see how the relationship works. Okay, so this solution is then deployed for the use with the final data set, for the remaining data set, which it learns from the same way as that of the training data set. This means that supervised machine learning algorithms will continue to improve even after being deployed, discovering new patterns and relationships as if it trains itself on the new data. Okay, so it means that here, even though this is has decided some model on the training data, but still it will go for maintaining or changing the data as per the given test data. Okay, so please read this carefully. I will give you 2 minutes for reading this. Please, this slide completely explains what is meant by a supervised learning. So let me show you this, read this plus slide, and then we'll go for the next slide to read. So, okay, next point is regarding unsupervised learning. Unsupervised learning, unsupervised machine learning. So, in case of supervised learning, we are having the labeled data, but here only we are having the input data. Input data previously in case of supervised learning also is given in a machine readable format. That is in terms of some data structures in some arrays, in some vectors or matrix, etc. But when it comes to the unsupervised machine learning, so we are having data in unlabeled format. Okay. unlabeled format, that is a human interference is not required. So unsupervised machine learning, it holds the advantage of being able to work with unlabeled data. So this means that human labor is not required to make the data set machine readable, allowing much larger data set to be worked by the program. So here it means if we are not giving the training data, it means that all the data will be a test data. Hence, a larger data set will be available for this unsupervised learning. Then next, in supervised learning, the labels allow algorithm to find the exact nature of the relationship between any two data points. Here, any two data points, if are belonging to the same class, whether these are belonging to another class, that is whether these two data points, what is the relationship between them, whether belongs to the same class or multiple class, etc. Whether this flower belongs to, or if I'm having data of 100 flowers, then first and third flower belong to the hibiscus, second and fourth belong to the mogra. It means we are learning about the relationship between these two data points. Then, however, unsupervised learning does not have labels to work on and resulting in the creation of hidden structures. So here, whenever we are not giving the labels, then whatever the hidden structures are there, that will be built or that is those will be created here. So relationship between data points are pursued by the algorithm in an abstract manner with no input required from the human being. So here, whatever the data points we are learning, if you wanted to say these two are related, etc. So those are done in the abstract manner. So human cannot interfere that yes, these two belong to the same class, these two belong to the another class, etc. Here, if we don't have the label, machine will itself learn that is which properties are similar, which are not, and based on that it will perform the output or classification, and because of which the human being interference is very less here. So then what are the hidden structures we have created is what makes unsupervised learning a versatile. Versatile, it means that it doesn't have a fixed structure. So one may find rule one, another may find another rule between the existing data. Okay, it is not the thing that each one will be able to find the same rule. No, here versatile, it means that many of the varieties are available. So instead of a defined and set problem statement, unsupervised learning algorithms can adapt to the data by dynamically changing hidden structures. So here, what are the existing hidden structures are there? So we can change those. So these operands are more deployment development than supervised learning algorithms. So whatever unsupervised learning and supervised learning algorithms are there. So this is having post deployment development, that is after the deployment. So this will go for the another changes into the item. So please read this slide. Okay. Then next, whatever the hidden structures or whatever the hidden patterns are there that we are creating. So that is making my unsupervised learning versatile. And here, hidden structures, these will be always changing. That is, with uh, it means here, for example, in terms of supervised learning, we know that this will be complete data will be divided into three classes based on the properties of whether this is flower or whether this is mogra or this is hibiscus or any other flower, etc. But in case of unsupervised learning, we don't have any fixed defined set problem. Okay, so it means that here unsupervised learning cannot have, yes, it will have the classification or it will have the classes, but here we are not here. It means in case of supervised learning, unsupervised learning, so whatever the hidden structures are there, so these will be always changing. That is because of which it is categorized into class 1, because of this it is categorized into class 2 or class 3, etc. So it means that whatever the hidden structure or whatever the model is there, it may change, okay, or it may be vary from person to person, the design by, etc. Okay, so this offers more post-deployment development than supervised learning algorithms. So initially, if we decided the classes, then after deployment or installation of that application also, it can go for the further scope or further development. That is the unsupervised learning. The next one is reinforcement learning. So this is, it means that learn from the errors. Okay, it means that we decided that this is will belong to the class, and later on I learned that that is not a correct because this model is wrong. So here we are learning from the errors. So it directly takes inspiration from how human being learns from data in their lives. Okay, it features an algorithm that improves upon itself and learns from new situations using a trial and error methods. Okay, so here we are using a trial and error methods and it grows, it means it learns itself. So favorable outcomes are encouraged or reinforced. Not favorable outputs are discouraged or punished. Okay, so reinforcement, it means that what is the encouragement or most likely to be followed approach. So based on the psychological concept conditioning, reinforcement learning works by putting the algorithm in work environment with an interpreter and a reward system. So psychological concept conditioning, that is, it will learn by using interpreter and reward system. In every iteration algorithm, the output result is given to the interpreter, which decides whether outcome is favorable or not. Okay, so here we decided a model, we given the output. So after giving the output, interpreter will decide whether this output or this class is correct or not. So correct, it is favorable. If not, it is undecided, or we can say the punished or discouraged approach. Then in case of program finding the correct solution, the interpreter reinforces the solution by providing a reward to the algorithm. So if in case we find out the correct solution, then reward. If not, if the outcome is not favorable, the algorithm is forced to reiterate until it finds a better result. Reiterate, it means that repeat until we get the result. Okay, reiterate, it means that again go for the iteration where we will find a better result. So in most cases, reward system is directly tied to the effectiveness of the result. So please read this definition for the reinforcement learning. Still there are 10 minutes. Please don't add the roll numbers. So we are still talking about the unsupervised learning. So unsupervised learning, we are talking about whether the results are favorable. If results are favorable, this it will have a reward. If results are not favorable, then it will go for the retread until we find the correct results or better results, etc. So here, uh, whatever reward system is there, that is effective. That is, it will have a much more effect. So then, in typical reinforcement learning use cases, such as finding the shortest route between the 2 points on map, a solution is not absolute value. Okay, here instead it takes one on a score of effectiveness expressed in percentage value. The higher this percentage value is, the more reward is given to the algorithm. So thus a program is trying to give the best possible solution for the best possible reward. So here this we complete a reinforcement learning. Now let us go for the next point, that is introduction to Bayes theorem. So let me know, have you heard about this Bayes theorem? Seems like we have listened somewhere this or studied somewhere. Can anybody able to recall this Bayes theorem? So here actually we are learning in terms of the implementations. Right now we studied about the three types of the machine learning algorithms: supervised, unsupervised, and uh, reinforcement. So now we are learning about the Bayes theorem, where we have seen the Bayes theorem previously. The answer is also on the slide. So we have seen in case of probabilities, that is the third chapter, we have seen the Bayes theorem, but we have seen only the partial part of this. The implementation yet we had not covered. So let us have some introduction for the Bayes theorem. So Bayes theorem is named for the English mathematician, which is Thomas Bayes, who worked extensively in decision theory, the field of mathematics that involves probabilities. So decision theory, it means that whenever we are taking a decision, for example, uh, should I choose this subject or this subject? So what can be the use of this subject? What can be the advantages of choosing this subject, disadvantages, and a second subject or third, fourth subject, etc. So here, decision, it means that if I take this subject, I cannot go for this another direction. Okay. So decision, it means that from this decision onwards, my other decisions will also affect, and I will have a complete different destinations based on my decision, or complete different environment based on my decision. So here the Thomas Bayes, this Bayes theorem is named after this mathematician, where probabilities are there. If I take this decision, what can be the probability, or what can be the transfer that this might be useful, this may not be useful, this is will have a higher score, this may not have the highest score, this is easy, this is difficult, this is useful, not useful, or this is useful, not useful. So probabilities, it means that out of these four subjects, which one might be most probably preferred by the users, or etc. So that is based on the probability case, and Bayes theorem is another, that is a case study of probability. So Bayes theorem is also used widely in the machine learning, where it is simple, effective way to predict classes with precision and accuracy. So here, this we are using for the determining or predicting the class of an item based on the precision and accuracy. So a Bayesian method of calculating conditional probabilities is used in machine learning applications that involve classification tasks. Okay, so here we are calculating the conditional probabilities. Again, here we are, it means applying the mathematical foundation for machine learning applications. Okay, so that involves classification tasks. Classification, where I wanted to divide the given items based on the data values into multiple classes. So Bayes theorem is method to determine conditional probabilities, that is probability of one event occurring given that another event has already occurred. Okay, so here we have seen the example, that is if students are passed into two tests. If a student is passed into first test, then what is probability that it might pass into the second test? That is, one event has occurred, the first test is already over, second test is already over, and I wanted to check what is the effect of first event, that is first test occurrence on the second test occurrence. I think I need to log out. Somebody else has logged on the device. So please, all of you, write your roll numbers into the chat window. We will stop the lecture at this point. So please, all of you, write your roll numbers into the chat window.